Hey, boys and girls. So today we are going to continue learning more about fossils. I am going to read you the Stemscopedia today. So if you would like to take your science notebook out and jot some notes down, that would be awesome. I am going to still put the Stemscopedia in the template for you to finish today so you can go back and reread and search for that information when you're completing your work for the day. All right, so let's begin. Seashells seem to be everywhere. Most of the time, you will find them on beaches, but some people have found shells stuck in rocks high on a mountain. There isn't an ocean for miles. How do you think a seashell got there? What does this tell you? What are fossils and how can we learn from them? Fossils are preserved parts or traces of animals or plants that lived in the past. Fossils are clues to the past. They tell us what organisms lived in a certain place. Fossils can tell us what the plant or animal looked like and what the environment was like where it lived. Fossils also show how plants and animals have changed over time. Some fossils look very familiar. Some fossils look unique. When we study a fossil, we can compare its characteristics to animals we know and see today. Some fossils look exactly like some of the organisms that we see around us. Other fossils only look slightly different. Plants and animals change over time. We can study these changes by studying old fossils. So down here, it's the fossilized fern leaf looks just like the fern leaves that we see today. There's the fossil, and then there's a fern. Figuring out the order of the layers is simple. Look at the photo on the right. It shows layers of rock. The layers of rock were formed one on top of the other. The bottom is the oldest layer, so it was laid down first. The top layer was laid down last, so it is the youngest layer. Imagine that you baked layers of a cake on Monday, Tuesday, Wednesday, and Thursday. Each day you used a different special ingredient. Monday was walnuts, Tuesday was raisins, Wednesday was cranberries, Thursday was chocolate chips. Monday's walnut layer is at the bottom, the Tuesday layer with raisins, then the Tuesday layer with raisins, and Wednesday's layer with cranberries would be next, and the chocolate chips in Thursday's layer would be on top. Monday's layer would be the oldest, Thursday's layer would be the youngest, or the most recent. What could your friend claim about the order the ingredients were used? Well, the walnut layer was baked first because it is the oldest layer. The raisins were added second, cranberries were added third, and the chocolate chips were added last. What does this have to do with the age of fossils? Think of the walnuts, raisins, cranberries, and chocolate chips as fossils. The rock layers, or how we use an example of the cake layers, in which fossils, or the special ingredients, are found help us know the ages of the fossils. So this was just so you can picture a visual in your mind. Fossils in the bottom layer are older than fossils in higher layers. Take a look at the diagram on the right. It shows fossils found in different layers of rock. What is the order of these fossils from oldest to youngest? Remember that these fossils are not the actual organisms themselves. Their body parts have been replaced with minerals and hardened into rock. So I would love for you to jot that down in your science notebook right now, just for notes. We're just taking notes. But tell me which fossils were the oldest to the youngest in this picture right here. All right. How can fossils tell us what environments were like millions of years ago? Scientists tell us that environments change over time. But what evidence backs up this claim? In 1988, a team of fossil hunters dug a hole in a desert in Peru. This desert is one of the driest places on Earth today. Almost no rain falls there. Dr. Gordon Hubble was a part of that team. He was an expert in shark fossils. He discovered a jawbone and more than 200 sharp, triangular teeth. Hubble recognized that the teeth belonged to an ancestor of the great white shark. Scientists figured out that the age of the fossil was 6.5 million years old. The conclusion? More than 6.5 million years ago, one of today's driest places was underwater. It was once a shark's habitat. Fossils proved that the environment in this place has greatly changed. And then over here it says, a great white shark bares its teeth. Today, the continent of Antarctica at Earth's south pole is the coldest place on our planet. Temperatures there can dive below negative 89 degrees Celsius or negative 102 degrees Fahrenheit. No plants or animals make their homes there permanently. Was Antarctica always that cold and empty of living things? According to fossil evidence, the answer is no. Scientists explored an area in Antarctica called the Dry Valleys and found fossils of mosses and tiny animals that were 14.1 million years old. These fossils were found in ancient lake beds where shrubs and insects flourished during warmer temperatures. Again, fossils prove that an environment on Earth has changed greatly over time. So, right here it says 14.1 million years ago, similar to Arctic tundra. Today, it's frozen over. So, that's what Antarctica looked like maybe 14.1 million years ago, and then today. Okay, so now we are looking to reflect. How can we represent fossils and past environments using models? Scientists often use models to describe objects or events in nature. A model is a representation of a real thing. A model can be as simple as a drawing or a shape made out of clay. It may be an animal reconstructed from just a few fossil bones. The dinosaur skeleton shown on the left is used to make a model of the complete dinosaur. Another type of model is a diorama that shows both the organism and its environment. The environment may be one of the present or the past. So now you're going to try. So it says the following chart lists 5 fossils that scientists have found and the locations on Earth where they were found. Based on the type of fossil found there, think about how the location has changed over time. In particular, decide whether each location, and there's 1, 2, 3, 4 of these, used to be a forest, used to be underwater, used to be a tropical island, has not changed since the fossil was formed. So you are going to be using these bullet points to plug into this table. So right here, it shows you the fossil, and let's go to the bigger picture of this. Okay, so the fossil, it shows you right here. Then we have where was it found, and then how do we think the location has changed? So if we found a seashell on the side of the mountain, do you think that maybe this area used to be a forest, used to be underwater, used to be a tropical island, has not changed since the fossil was formed? Well, when we think about a seashell, we don't usually find those on the side of a mountain. So I would say, well, it could have possibly been used to be underwater or used to be a tropical island. My vote would probably be more towards they used to be underwater. A palm branch. Where was it found? An ice sheet in the Arctic. Well, a palm branch is like, think of like a palm tree branch. And in the Arctic, I don't know about that one. You guys are going to have to tell me. Did it used to be a forest, used to be underwater, or used to be a tropical island, or maybe it has not changed since the fossil was formed? So these answers are what you're going to plug in for each fossil and where it was found. Please let me know if you guys have any questions at all. And don't forget, you can always go back and listen to the Stemscopedia again, or just, search within the text, because that's a very good strategy for information readers. Always go back and dig in the text and see if you can find that answer.